Hello, in this lecture we will find the radius of a circle. In the drawing you can see a circle. The center of this circle is at point O, and the size of chord AD is 10 units, and the size of chord BC is 5 units, and this angle equals to 90 degrees. And we want to find out the radius of this circle. Okay. First of all, we will define what is peripheral angle. A peripheral angle is an angle in the circle that its vertex is on the circle, that is to say, the vertex of a peripheral angle is a point on the circle, and its curves are chords in the circle. So I will read again the definition of a peripheral angle. A peripheral angle is an angle in the circle that its vertex is on the circle and its curves are chords in the circle. Okay, now I will give you an example in order to clarify the definition. Okay. So in this circle, angle alpha is a peripheral angle. First of all, angle alpha is in the circle, and the vertex of angle alpha is at point A, and point A is a point on the circle. Okay? And also curve AC of angle alpha is a chord or string in the circle, and also chord AB or string AB is, or curve AB is a chord or string in this circle. Okay, so again, angle alpha is a peripheral angle because it is in the circle, and its vertex is at point A, a point in the circle, on the circle itself. Point A is a point on the circle, and vertex A is at point A. The vertex of angle alpha is at point A, and point A is on the circle, and curve AC of angle alpha is a chord in the circle, and also curve AB of angle alpha is a chord in this circle. For that reason, angle alpha is a peripheral angle. Okay, so again I will read the definition of peripheral angle. Peripheral angle is an angle in the circle that its vertex is on the circle. The vertex of angle alpha is at point A, and point A is a point on the circle itself, and its curves are chords in the circle. The curves of angle alpha are chords of this circle. Curve AC of angle alpha is a chord in this circle, and curve AB of angle alpha is a chord in this circle. For that reason, angle alpha is defined as a peripheral angle. Okay? So, actually, that is the definition of a peripheral angle. So, now we will return to our circle, and in the next step we will draw a string through points A and O. You should remember that point O is a center of this circle, and we will draw a chord through points A and O. Okay? We will define the touching point between the string and the circle as point M. Actually, chord AM is the diameter of this circle. I will write it down. Chord AM that we drew is the diameter of the circle. why chord AM is the diameter of this circle? Because of the fact that chord AM passes through points O, that is the center of this circle. Okay, so chord AM is the diameter of the circle because it passes through the center of the circle. That is to say, it passes through point O, that is the center of this circle. Okay, point O. Okay, so I will read again what I wrote. Chord AM is the diameter of the circle because it passes through the center of the circle, that is to say, it passes through point O, that is the center of the circle. Point O is the center of the circle, and chord AM passes through the center of the circle. For that reason, chord AM is the diameter of this circle, because any chord that passes through the center of the circle is defined as the diameter of the circle. Okay, so AM is the diameter of this circle, or chord AM is the diameter of this circle. Okay, so in the next step we will connect together points M and D by a straight line. And as you can see from the drawing, angle ADM rests on AM, that is the diameter of this circle. Again, angle ADM rests on AM, that is the diameter of this circle. And we have rule number 1, that states that a peripheral angle that rests on the diameter of the circle equals to 90 degrees. Okay, I will read rule number 1 again. Rule number 1 states that a peripheral angle that rests on the diameter of the circle equals to 90 degrees. I will show you an example in order to clarify the rule. So, if chord AB is the diameter of this circle, any angle that rests on chord AB will be equal to 90 degrees. So if we have peripheral angle that rests on chord AB, that is the diameter of this circle, it will be equal to 90 degrees. So actually the red angle rests on the diameter of the circle, that is to say on chord AB. So according to rule number 1, it equals to 90 degrees. Angle AOB, according to rule number 1, angle AOB equals to 90 degrees. Because it rests on the diameter of the circle. Because of the fact that angle AOB rests on the diameter of this circle, that is to say it rests on chord AB, according to rule number 1, angle AOB equals to 90 degrees. Okay? Angle AOB equals to 90 degrees because it rests on the diameter of this circle. And if we have other angle, angle ACB also rests on the diameter of this circle, and according to rule number 1, it also will be equal to 90 degrees. Okay, angle ACB equals to 90 degrees according to rule number 1, that states that any angle that rests on the diameter of the circle equals to 90 degrees. Angle ACB rests on chord AB, that is the diameter of this circle. For that reason, according to rule number 1, it equals to 90 degrees. Okay? So that is the explanation of rule number 1, that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. Okay, and we can actually implement this rule in our circle, because in our circle uh, before that we will connect together points A and B. Okay, as I've already told you, angle ADM, I write it down, angle ADM rests on chord AM, that is the diameter of this circle. Angle ADM rests on chord AM, that is the diameter of the circle, and for that reason according to rule number 1, it equals to 90 degrees. Okay, again, angle ADM, that is a peripheral angle, rests on chord AM, that is the diameter of this circle, and for that reason, according to rule number 1, it equals to 90 degrees. So actually this angle equals to 90 degrees according to rule number 1, that states that any peripheral angle that rests on the diameter of the circle equals to 90 degrees. For that reason, angle ADM that rests on chord AM, that is the diameter of this circle, equals to 90 degrees. Okay, so I will read again what I wrote. Angle ADM rests on chord AM. Angle ADM rests on chord AM, that is the diameter of the circle. For that reason, according to rule number 1, it equals to 90 degrees. Okay? so angle ADM that rests on the diameter of this circle equals to 90 degrees according to rule number 1 that states that any peripheral angle that rests on the diameter of the circle equals to 90 degrees. For that reason, angle ADM equals to 90 degrees. Okay, so now we will focus on the right triangle ADM. ADM is a right triangle because angle ADM equals to 90 degrees. So in a right triangle ADM, we will define angle AMD as angle alpha. Angle AMD will be defined as angle alpha. I will write it down. Angle AMD equals to angle alpha. Okay, angle AMD defined as angle alpha, or angle AMD equals to angle alpha, and angle MAD will be equal to angle beta. Angle MAD will be equal to angle beta. So I write it down. Angle MAD will be defined as angle beta. Okay, so in a right triangle ADM, angle AMD equals to alpha and angle MAD equals to beta. Okay, we know that the sum of the angles in any triangle equals to 180 degrees, and it is especially true in the right triangle ADM. Okay, so we'll create equation number 1 that states that the sum of the angles in the right triangle AMD equals to 180 degrees. So actually alpha plus beta plus 90 degrees equals to 180 degrees. So our first equation states that alpha plus beta plus 90 degrees, that is the sum of the angles on the right triangle ADM, equals to 180 degrees, and it is true for any triangle. For any triangle in the world, the sum of its angles equals to 180 degrees, especially in the right triangle ADM. Now we will subtract 90 degrees from equation number 1. So we subtracted 90 degrees from equation number 1. Alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta. and 180 degrees minus 90 degrees equals to 90 degrees. In the next step, we will subtract alpha from equation number 1, from this equation. So we subtracted alpha from this equation. We got that alpha plus beta minus alpha equals to beta. 90 degrees minus alpha equals to 90 degrees minus alpha. So we have equation number 1 that states that beta, angle beta equals to 90 degrees minus alpha. Okay? And in the next step, we will connect together points A and B by a straight line. Okay, we connected together points A and B by a straight line. And we will define this point L, so actually the vertex of the 90 degrees angle is defined as point L. So now we will focus on the right triangle ABL. So on the right triangle ABL, we have angle ABD that rests on chord AD, and angle alpha also rests on the same chord, that is to say on chord AD. Okay, I write it down. In the right triangle ABL, angle angle ABD rests on chord AD. So first of all, we will focus on angle ABD. Actually, angle ABD rests on chord AD. and angle alpha, that is angle AMD, also rests on chord AD. So actually angle AMD that equals to angle alpha rests also on chord AD. Okay, so angle ABD rests on chord AD, angle ABD rests on chord AD, and angle AMD equals to angle alpha also rests on chord AD. Angle AMD that equals to angle alpha also rests on the same chord AD. Okay, and we actually have rule number 2 that states that peripheral angles that rests on the same chord or the same arc equal to each other. So I will read rule number 2 again. Rule number 2 states that peripheral angles that rests on the same chord or same arc equal to each other. Now I will give you an example in order to clarify rule number 2. So actually, if we have two peripheral angles that rests on the same chord or same arc, for example, we have peripheral angle alpha so this is peripheral angle alpha, peripheral angle alpha rests on chord BC, and we have another peripheral angle beta that also rests on the same chord, so peripheral angle beta rests also on chord BC. So peripheral angles alpha and beta, both of them rest on the same chord BC. Therefore, according to rule number 2, angle alpha equals to angle beta. Okay, so I will write it down. According to rule number 2, we can deduce that angle alpha equals to angle beta because of the fact that both those two angles rest on the same chord BC. Okay, they both rest on the same chord BC because they both angles rest on the same chord, that is to say chord BC. Because of the fact that both angles alpha and beta rest on the same chord, that is to say on chord BC, according to rule number 2, they equal to each other, that is to say angle alpha equals to angle beta. So if you have two peripheral angles that rest on the same chord, they are equal to each other. And actually the same rule is correct, and we can say that if both angles rest on the same arc, they are also equal to each other. But actually, if they rest on the same chord, they must also rest on the same arc. Okay, as you can see here, both angle alpha and beta rest on chord BC, but both of them also rest on the same arc BC. Okay, so anyway, what is important to us is that both angle alpha and beta rest on the same chord BC. Therefore, they are equal to each other. Alpha equals to beta according to rule number 2. Okay, so we actually can implement the rule in our circle. As I've already written, angle ABD rests on chord AD, and angle AMD that equals to alpha rests also on chord AD. Okay, so as you can see here, angle ABD rests on chord AD, and angle alpha also rests on the same chord AD. So according to rule number 2, they are equal to each other. Okay, again, angle ABD rests on chord AD. Angle ABD rests on chord AD, and angle AMD that equals to alpha also rests on the same chord AD. Angle AMD that equals to alpha also rests on the same chord AD. So according to rule number 2, angle ABD also equals to angle alpha. Okay, so we write it down. So according to rule number 2, angle ABL also will be equal to angle alpha. Okay, because of the fact that angle ABL rests on the same chord as angle alpha, according to rule number 2, angle ABL will be also will be equal to alpha. Okay, because of the fact that angle ABL rests on chord AD, and angle alpha also rests on the same chord AD, they are equal to each other. That is to say, angle ABL equals to angle alpha. Okay, so actually we can write here that angle ABL equals to angle alpha. Okay, angle ABL this angle ABL also equals to angle alpha because of the fact that it rests on chord AD, and angle alpha also rests on the same chord AD. So according to rule number 2, angle ABD will be also equal to angle alpha because they both rest on the same chord AD. Okay, so now we will focus on the right triangle ABL. And in the right triangle ABL, we will define angle LAB as X. Okay, this angle will be defined as angle X. Again, angle LAB will be defined as angle X. Again, angle LAB or angle BAL, it is the same, will be defined as angle X. Okay, angle LAB equals to angle X. Okay, in the right triangle ABL, angle LAB is defined as angle X, or angle LAB equals to X. In this right triangle, the sum of the angles equals to 180 degrees, and it is true for all the triangles in the world. The sum of the angles equals to 180 degrees, and especially it is true for the right triangle ABL. The sum of its angles equals to 180 degrees. So I write it down. This will be our second equation. So our second equation is that alpha plus x plus 90 degrees, that is the sum of the angles in the right triangle ABL. Alpha plus x plus 90 degrees equals to 180 degrees, because in any triangle in the world, the sum of its angles equals to 180 degrees, and especially in the right triangle ABL, the sum of its angles equals to 180 degrees. So I created equation number 2 that states that the sum of the angles in the right triangle ABL equals to 180 degrees. That is to say, alpha plus x plus 90 degrees, that is the sum of the angles in the right triangle ABL, equals to 180 degrees. Okay, the sum of the angles in the right triangle ABL, that is to say alpha plus x plus 90 degrees, equals to 180 degrees. Okay, so this will be our second equation. In the second equation, we'll subtract 90 degrees from the second equation. So we subtracted 90 degrees from this equation. Alpha plus x plus 90 degrees minus 90 degrees equals to alpha plus x, and 180 degrees minus 90 degrees equals to 90 degrees. Here we'll subtract alpha from the second equation. So we subtracted alpha from this equation. Alpha plus x minus alpha equals to x. 90 degrees minus alpha equals to 90 degrees minus alpha. So we got that x equals to 90 degrees minus alpha. This is our second equation, but from the first equation, we know that beta also equals to 90 degrees minus alpha. So the first equation states that beta also equals to 90 degrees minus alpha. So I write it down. So according to the first equation, beta also equals to 90 degrees minus alpha. Okay? According to the first equation, beta also equals to 90 degrees minus alpha. So we can deduce from those both equations that beta equals to x, or in the long way we can write down that 90 degrees minus alpha equals 90 degrees minus alpha. Okay, in the long way we'll write that 90 degrees minus alpha equals to 90 degrees minus alpha. So we can substitute 90 degrees minus alpha by beta, because beta equals to 90 degrees minus alpha, and we can substitute 90 degrees minus alpha in this side of the equation by x, because x equals to 90 degrees minus alpha, and then we will get that we can do it in opposite way. We'll substitute x by 90 degrees minus alpha, because x equals to 90 degrees minus alpha, and we'll substitute 90 degrees minus alpha in this side of the equation by beta, because beta equals to 90 degrees minus alpha. So we will get that x equals to beta. Okay, so I've already said we substituted 90 degrees minus alpha by x, because big x equals to 90 degrees minus alpha, and we substituted 90 degrees minus alpha by beta, because beta equals to 90 degrees minus alpha, and we got the equality that x equals to beta. Okay, so actually x equals to beta, so instead of x here we can write down that angle BAL equals to beta, because beta equals to x equals to beta, yes? So we can substitute x by beta. Okay, so instead of x we will write down beta. So angle BAL equals to beta. Okay, and now I will write down the third rule. Rule number 3. Rule number 3 states that equal peripheral angles rests on equal chords / arcs. Okay, equal peripheral angles rests on equal chords or equal arcs. Okay, instead of or I will write slash. Okay, again I will I will read again equation number 3. I will read again rule number 3. Rule number 3 states that equal peripheral angles rest on equal chords or equal peripheral angles rest on equal arcs. Okay, instead of or I use the sign slash. The sign slash means the word or. Okay, equal peripheral angles rest on equal chords or equal arcs. So in order to clarify rule number 1, I will give you an example. So if we have two peripheral angles that equal to each other, so if this peripheral angle equals to alpha, and we have another peripheral angle that also equals to alpha, okay, we have two peripheral angles that both of them equals to alpha. Then, according to rule number 3, that equal peripheral angles rest on equal chords or arcs, we can deduce that chord BC equals to chord EF. Okay, so I write it down. Because of the fact that angle EDF equals to alpha and angle BCA also equals to alpha, we can deduce from rule number 3 that chord EF equals to chord BC. Chord EF equals to chord BC because this angle equals to this angle. For that reason, this chord equals to this chord. Because of the fact that both of those angles equal to each other, they rest on equal chords. That is to say, EF equals to BC. Okay? Again, equal peripheral angles. This angle is angle alpha and this angle is angle alpha. Both peripheral angles are equal to each other. For that reason, according to rule number 3, they both rest on equal chords. That is to say, EF equals to BC, or angle alpha that rests on chord EF equals to BC, that is the angle CAB rests on, or angle EDF that rests on chord EF equals to the chord that angle BAC rests on. Angle BAC also rests on chord BC, so they both rest on equal chords. That is to say, BC equals to EF. Okay, so equal peripheral angles rest on equal chords. This angle equals to this angle. For that reason, this chord equals to this chord. They both rest on equal chords because they equal to each other. So EF equals to BC. Okay, so that is the explanation of rule number 3, and we actually can implement rule number 3 in our circle. As you can see, angle BAL, or we can say also angle BAC is the same. Angle BAC, I will write it down. Angle BAC equals to angle beta, and also angle AMD equals to angle beta. Both of them equals to beta. So according to rule number 3, they both rest on equal chords. So I write it down. According to rule number 3, they both rest on equal chords. So read again. Angle BAC that equals to beta and angle MAD that equals also to beta. So we have two peripheral angles that equal to each other. So according to rule number 3, they both rest on equal chords. That is to say, BC, and this angle beta rests on chord BC, equals to MD, because this angle beta rests on chord MD. So we can deduce from rule number 3 that BC equals to MD. BC, chord BC equals to chord MD. Because of the fact that this angle is angle beta and this angle beta rests on chord BC, so this chord BC will be equal to the chord that this angle beta rests, and this angle beta rests on chord MD. So BC equals to MD because equal peripheral angles rest on equal chords. This angle beta rests on BC and this angle beta rests on MD, and they rest on equal chords. So chord BC equals to chord MD. So according to rule number 3, chord BC equals to chord MD. Okay? But we know it is given us in the question that BC equals to 5 units. Okay, we know from the question that BC equals to 5 units. Okay, we know that BC equals to 5 units. So we can deduce from it, because of the fact that BC equals to MD and BC equals to 5 units, we can deduce from these two expressions that MD also equals to 5 units. Okay, MD also equals to 5 units. Okay, we know that BC equals to MD and BC equals to 5 units, so we can deduce from it that MD also equals to 5 units. Okay? So we can write here that MD equals to 5 units. Now I will draw again the right triangle AMD. You should remember that AM is the diameter of this circle, and the diameter of any circle equals to 2 times the radius. So we will define chord AM as D because it is the diameter of the circle. So this is the right triangle AMD. side AD of this right triangle equals to 10 units, side MD equals to 5 units, and the hypotenuse AM of the right triangle equals to D, that is the diameter of the circle. And we know that the diameter equals to 2 times the radius. So after we will find out the value of D, we will divide it by 2 and we will get the radius of the circle. Okay? As you can see here, it is a right triangle. DM is a right triangle. So we actually can use the Pythagorean theorem in order to find out the hypotenuse of this right triangle, because we know the values of the perpendiculars of these right triangles. So first of all, I will write down the Pythagorean theorem. As I've already told you, the Pythagorean theorem applies only to right triangles. So the Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read again the Pythagorean theorem. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? So we actually can implement the Pythagorean theorem in our circle, in our right triangle. So in our right triangle, the square of the hypotenuse, it is AM square, equals to the sum of the squares of the perpendiculars. So it is AD square plus MD square. Okay, according to the Pythagorean theorem, the square of the hypotenuse, that is to say AM square, because AM is the hypotenuse of this right triangle MDA, equals to the sum of the squares of the perpendiculars. So the sum of the square of the perpendiculars, it is md square plus ad square. Okay, this is the square of the perpendiculars, ad square plus md square. But we know that am equals to d, md equals to 5, and ad equals to 10. So we can put the data in question number 3, and we will get that d square equals to 10 square plus 5 square. Okay, ad equals to 10, md equals to 5, and am equals to d. So instead of md substituted by 5, instead of we substituted ad by 10, and we substituted am by d. Okay, so we got that d square equals to 10 square plus 5 square. Okay, d square equals to 10 square plus 5 square. 10 square is 100, 5 square is 25, 100 plus 25 is 125. So I write it down. So we got that d square equals to 125. Now we'll take a root out of equation number 3. So we took a root out of equation number 3, we got that d equals to root of 125. 125 equals to 25 times 5. So I write it down. Okay, 125 equals to 25 times 5. Now we can split the root to 2 roots according to the rule that the root of AB equals to root A times root B. So according to this rule that the root of A times B equals to root A times root B, we can split this root to 2 roots. So we'll do it now. Okay, we splitted this root to 2 roots according to this rule. We know that the root of 25 is 5, so I write it down. Okay, we got that the d, that is the diameter of the circle, equals to 5 times root 5. So we know that the d is the diameter of the circle. So we can write the fourth equation that states that d, that is the diameter of the circle, equals to 2 times the radius. And we also know, according to the further question, that d equals to 5 times root 5. We know that the diameter of any circle equals to 2 times the radius. It is true for every circle, especially for our circle. And we got the result that the value of d equals to 5 times root 5. So I wrote it here. So actually we can substitute d in the fourth equation by 5 times root 5, because d equals to 5 times root 5. Okay, so in the fourth equation I substituted d by 5 times root 5, because d equals to 5 times root 5. We got that 5 times root 5 equals to 2 times the radius. Now we will divide equation number 4 by 2, and we will get that the radius of the circle equals to 5 times root 5 over 2. Okay, so we divided equation number 4 by 2, and we got that the radius of the circle equals to 5 times root 5 over 2. So this is over 2 units, okay? It is 5 times root 5 over 2 units. And we could also say that the radius of this circle, equals to 5.59 units. Okay, so the answer to the question is that the radius of this circle equals to 5.59 units, or it equals to 5 times root 5 over 2. Okay, so that is the answer to our question. Now I will summarize the lecture. Actually, we wanted to find the radius of this circle. We know that chord AD equals to 10 units and chord BC equals to 5 units. And point O is the center of the circle, and this angle ALB equals to 90 degrees, and we want to find out the radius of this circle. Okay, first of all, we defined what is a peripheral angle. Actually, a peripheral angle is an angle in the circle that its vertex is on the circle and its curves are chords in the circle. So actually this is the example of a peripheral angle. Angle alpha is a peripheral angle because first of all it is an angle in the circle, and the vertex of angle alpha is at point A, and point A is a point on the circle, and half AC of angle alpha is a chord in the circle, and also half AB of angle alpha is a chord in this circle. Okay, so an peripheral angle is an angle in the circle that its vertex is on the circle. A is the vertex of angle alpha and it is on the circle, and its curves are chords in the circle. Curve C is a chord in this circle, and curve AB of angle alpha is a chord in this circle. So this is actually the definition of peripheral angle. Okay. In the next step, we actually draw chord for points A and O, and record to the touching point between the chord and the circle point M, and actually chord AM is the diameter of the circle because of the fact that it passes through the center of the circle, that is to say through point O. For that reason, chord AM is the diameter of this circle. Okay, and then we connected together points M and D by a straight line. Okay, and we have rule number 1 that states that a peripheral angle that rests on the diameter of the circle equals to 90 degrees. So I will give you an example what rule number 1 states. Rule number 1 states that if we have the diameter of this circle, if the diameter of the circle is chord AB, and we have any peripheral angle that rests on the diameter of the circle equals to 90 degrees. The red angle rests on AB, that is the diameter of this circle. For that reason, angle AOB equals to 90 degrees. And in the same way, angle ACB rests on AB, that is the diameter of this circle. For that reason, angle ACB equals to 90 degrees. Okay, so that is the explanation of rule number 1. And we can implement rule number 1 in our circle because angle ADM rests on the diameter of the circle, that is to say on chord AM, that is the diameter of this circle. For that reason, according to rule number 1, it equals to 90 degrees. Okay, so according to rule number 1, angle ADM that rests on the diameter of this circle equals to 90 degrees. Okay, because AM is the diameter of this circle, and angle ADM rests on AM, that is the diameter of the circle. For that reason, it equals to 90 degrees. Okay, and then we define angle AMD is alpha, angle AMD equals to alpha, and we defined angle MAD is beta. Okay, in the right triangle AMD, we have this angle alpha and this angle is beta. Okay, but we also know that the sum of the angles in any triangle equals to 180 degrees. So we created equation number 1 that states that the sum of the angles in the right triangle AMD equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. Okay, that is exactly equation number 1. Alpha plus beta plus 90 degrees equals to 180 degrees. Okay, we substituted 90 degrees for this equation, then we substituted alpha, and we got that beta equals to 90 degrees minus alpha. Okay, so that is our first equation that says that beta equals to 90 degrees minus alpha. In the next step, we connected points A and B together by a straight line, and we actually have rule number 2 that states that peripheral angles that rest on the same chord or the same arc equal to each other. So I will give you an example to clarify the meaning of rule number 2. We have here two angles, two peripheral angles, angle alpha and angle beta, and those two peripheral angles rest on the same chord, that is to say on chord BC. Angle alpha rests on chord BC and angle beta rests on the same chord BC. So according to rule number 2, because of the fact that both those two angles rest on the same chord, according to rule number 2, they are equal to each other. That is to say, alpha equals to beta because of the fact that they both rest on the same chord BC. Okay? So if we have two peripheral angles that rest on the same chord, or they can rest also on the same arc, it is the same, they are equal to each other. Alpha equals to beta because both of them rest on the same chord BC. So we actually can implement this rule in our circle because we actually have angle ABD, angle ABD rests on chord AD, and also angle AMD rests on the same chord AD. So we have two angles, angle ABD and angle AMD, that is angle alpha, that both of them rest on the same chord, on chord AD. For that reason, according to rule number 2, they are equal to each other. So angle ABD also equals to angle alpha because of the fact that both angles rest on the same chord AD. Angle alpha rests on chord AD and angle ABD also rests on the same chord AD. For that reason, angle ABD also equals to angle alpha, according to rule number 2. So, or we can say that Okay, so we can say that angle ABL equals to angle alpha because uh, this angle ABL or ABD, it is exactly the same, rests on the same chord as angle alpha. They both rest on chord AD. For that reason, this angle also equals to angle alpha, according to rule number 2. Okay, so now we'll focus on the right triangle ABL. We defined this point as point L, and in the right triangle ABL we defined angle BAL as angle X, and we know that the sum of the angles in any triangle in the world equals to 180 degrees, and especially in the right triangle ABL, the sum of its angles equals to 180 degrees. For that reason, we can actually say that x plus alpha plus 90 degrees equals to 180 degrees, and that was our second equation that states that the sum of the angles in the right triangle ABL equals to 180 degrees, or alpha plus x plus 90 degrees equals to 180 degrees. Okay, and from equation number 2 we got that x equals to 90 degrees minus alpha. But from equation number 1 we know that beta also equals to 90 degrees minus alpha. So x equals to 90 degrees minus alpha, and beta also equals to 90 degrees minus alpha. We can deduce from it that x equals to beta. So we can actually substitute x in this angle BL that is defined as angle X. We can substitute it by beta because x equals to beta. Okay, so we have angle BAL that equals to beta, and we have also angle MAB that also equals to angle beta. So both of those angles, those peripheral angles, equals to beta. And we have rule number 3 that states that peripheral angles that equal peripheral angles rest on equal chords or equal arcs. So I will explain again the meaning of rule number 3. If we have equal peripheral angles, this is angle alpha and this is also angle alpha, so they both equal to each other. According to rule number 3, they also rest on equal chords. That is to say, BC equals to EF, because equal peripheral angles rest on equal chords. That is to say, BC equals to EF. Okay, so if we have two peripheral angles that equal to each other, then they also rest on equal chords. That is to say, BC equals to EF. Okay, so this is the explanation of rule number 3. When we can implement rule number 3 in our circle, we have angle BAC that equals to beta, angle BAL equals to beta, angle angle BAC, angle BAC equals to beta. That is what we found out, that angle BAL equals to beta, and angle MAD also equals to beta. So according to rule number 3, equal peripheral angles rests on equal chords. That is to say, angle BAC that rests on chord BC equal chord BC equals to chord MD, because equal angles, this angle is better and this angle is also better. Equal peripheral angles rest on equal chords. This angle rests on chord BC, and this the same angle better rests on chord MD. For that reason, they both BC equals to MD, because equal angles rest on equal chords. That is to say, BC equals to MD because this angle is better and this angle is also better, so they both rest on equal chords. If this angle rests on BC and this angle rests on MD and they equal to each other, also BC equals to MD because equal angles rest on equal chords. Because of the fact that this angle equals to this angle also rests on the same and on equal chords. The BC equals to MD. Okay, this angle equals to this angle, so this angle rests on BC and this angle rests on MD, so they rest on equal chords. That is to say, BC equals to MD. Okay, so according to rule number 3, BC equals to MD, but we know that BC equals to 5 units. It is given us in the question. BC equals to 5 units, and we know that BC equals to MD, so we can deduce from this expressions that MD also equals to 5 units. Okay, MD also equals to 5 units. Okay, now we have the right triangle AMD. We will draw it again. So we draw right triangle AMD again. Side AD of the right triangle equals to 10 units, side MD equals to 5 units, and AM is the diameter of the circle, so we mark it as D, that is the abbreviation for diameter, and we can implement the Pythagorean theorem in order to find out the value of D. That is also the hypotenuse of this right triangle. So according to the Pythagorean theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So it is right only in the right triangles. So we can implement this theorem in our right triangle, and we can say that the square of the hypotenuse, that is AM square, equals to the sum of the squares of the perpendiculars, that is to say, equals to MD square plus AD square. Okay, so according to the Pythagorean theorem, AM square equals to AD square plus MD square. But we know that AM equals to D, so we can substitute AM by D. And we know that AD equals to 10 units, so we can substitute AD by 10. And we know that MD equals to 5 units, so we can substitute MD by 5. Okay, so we substituted these variables. We put it in equation number 3, and we got that the D equals to 5 times root 5. Okay, D equals to 5 times root 5. So we know that d equals to 5 times root 5, but we also know that in any circle in the world, the diameter equals to 2 times the radius. This is true for every circle in the world, that the diameter equals to 2 times the radius. So in the fourth equation, we can substitute d by 5 times root 5, because d equals to 5 times root 5. So we substituted d by 5 times root 5. So 5 times root 5 equals to 2 times the radius. We can divide the fourth equation by 2, and we got that the radius of this circle equals to 5 times root 5 over 2 units. Or in numbers, we can say that the radius of the circle equals to 5.59 units. So the radius of this circle equals to 5.59 units, or it equals to 5 times root 5 over 2 units. Okay, thank you very much.